So here we have chapter 4, Newton's law, principle 18, the principles for chapter 4. And then this is our what causes motion, nothing causes motion. We have the first law, which is a body at rest will stay at rest, or a body in motion will stay in motion until a force is acting on the body. Right, so we have forces do not cause motion, forces cause a change in the motion. And we know that force is mass times acceleration. And the velocity is force times time divided by mass. Right. We have the second law, which is the rate of change of an object's velocity or the acceleration is proportional to the force and inversely proportional to its mass. So we have our change in velocity divided by our change in time, which equals acceleration, which acceleration equals force divided by mass. Here we have the third law, where for every action there's a reaction. This is known as the reaction force, right? So we have object 1, which is pushing 50 newtons onto a wall, while the wall, which is object 2, pushes 50 newtons back and makes equilibrium. So my hand, let's say X puts on 20 newtons onto the table is pushing back 20 newtons as well, right? So F1 of 2 is equal to the negative F2 of 1, other way around as well, which they're all equal to 0. We have the momentum of objects, which is momentum equals P, equals mass times velocity, which is known in kilograms times velocity, right? Mass, velocity. Okay, so if you have an example, the car that moves 10 meters per second. So we have the weight times the velocity, which is 10,000 kilometers per second in the I direction. Here's another example. So they have the same velocity, different momentum due to weight. You see they both have 10 as their velocity. However, this is 60 kilograms, one is 1,000. So they come out with a different solution. Right, now here we have this is just here, this turns into this by system of operations. And so V1, V2 becomes a change in velocity. We have units of force, which is our force net, or net force, equals mass times acceleration, which equals our momentum, change of momentum divided by our change of time. So unit of forces are in newtons. 1 newton is the force that is acting on an object of mass 1 kilogram, produce an acceleration of 1 meter per second squared. So here we have a little example of a 1 kilogram box, which has a force of 1 newton because its acceleration is 1 meter per second. So 1 times 1, 1 newton. Here we have the newtons can be found in many ways. 2 newtons equals 2 times 1, 2. Right? Now it's switched. Half 0.5 kilograms times 4 also equals 2 newtons. They all have the same outcome, just different weights and acceleration. Here we have a net force, which is F1, F2 is net. So here we have F1, F2. We're going to move F2 to the head of F1, which creates our net force, right here, which produces acceleration. So here we have it equals to 0 is at equilibrium because our net force is equal to 0. F1 plus F2 equals 0. They're both going in the opposite direction. That means our acceleration's at 0 times whatever mass, doesn't matter, always equals 0. Okay. Examples of force. You can push or pull a spring. I think you did it wrong in the video because you said string, but it's a spring. You have tension force and normal force. So here it's normal. It's not being compressed or pulled. Here it's being pulled, which is the force going that way because the spring is making the box come back. Here it's compressed, which it wants the box to move this way to come back to normal, right? And then we have tension on a box. Here we have normal force, where it's the floor is pushing back on the person standing on the floor with their weight. Their weight is mass times gravity. So here it says an electromagnetic force and is an electromagnetic force that the floor exerts on the object, while the weight is the gravitational force that the earth exerts on the guy. Two mysterious forces exist, and they are invisible forces, so you don't see gravity and the force that pushes back up. Here we have friction forces, which is also invisible. You don't see friction, right? So friction forces always have the opposite direction of the velocity of the object. So this box is moving this way on a rough surface. The friction is pushing it the other way. This vector is going the other way. So you have the fundamental forces of the universe, which are electromagnetic force, the weak nuclear force, the strong nuclear force, and the gravitational force. Gravitational force pulls you down. And these forces are the forces that can make a change in the motion of an object.